How's it going, guys? I'm Brian Boomer, and today we're going to talk about environmental controls. Today I've got Cutro with Triclean Air with us. How you doing, Cutro?
Doing very well, doing very well.
Awesome, man. Why don't you introduce yourself and tell us a little bit about your company real quick?
Um, my name is Michael Cutro, and Triclean Air is an environmental solutions company. We mainly specialize in manufacturing commercial HVAC equipment, primarily hydronic solutions and water treatment solutions for more of a large scale client base. But we also do manufacture some products for everyday users as little as the tent guy. um, it's kind of the base of what we do.
Nice. Well, awesome, man. Well, I got a few questions for you, and I think everybody watching will really enjoy some of the answers. I know you and I got a chance before to kind of discuss, business and see where the application fits with some of my clients. But I think today's questions will really help kind of give that basic to advanced kind of answers for anybody that's watching. One of the first ones is from your perspective is what's the biggest environmental mistakes that you see for indoor and greenhouse growers?
So it's different on both from indoor to greenhouse, but one of the things you see is people implementing and following old information and thinking that nothing has changed over the period of, let's even just use 5 years, right?
Right.
10 is even longer. But, when we first started doing all this, at least I speak for myself, 20 years ago, it was pretty easy to figure stuff out. If you had a basic understanding of, what a watt was and what a BTU is, and you can do conversion and you kind of get an answer that back then used to work great. When you're pushing the parameters of 1 pound of light back then, um, it's pretty easy to control your space if you got enough of AC to cover the sensible, which is the heat load that you and I feel and know. Um,
Right.
that's not the case anymore. Now we're taking the same space and we're adding 3 times the volume of plant mass inside of it, feeding the plant 3 times as much moisture to roughly. Um,
Right.
Now those numbers don't work anymore. So that's one of the biggest environmental mistakes I see is people go into it thinking that it's just 1 watt, convert your wattage to BTUs, and then that's going to be good to solve your problem.
Right, for cooling. Yeah, and definitely greenhouse, just depending on where you're at climate wise, heat, humidity, cold temperatures definitely play a bigger variable. Indoor being a little bit more insulated, I think has a little bit different of an application, but you're right, it's a lot of plant mass and moisture. And on that topic, how do temperature and humidity interact, and why does that matter for plant health?
So the plant needs to have a certain amount of pressure. We call it kind of BPD, or that's the term that
Yeah,
industry and other industries use. So your temperature and humidity have to correlate in order to put the plant into a situation in which it's going to utilize and basically burn energy at the best rate. And that energy kind of is, if you think of it, is supplemented through light, um, air, which would be, let's say, CO2 increasing, and then food, from a root base. So the better environment that you can get that plant into, it's going to utilize all of those inputs more efficiently and make them more readily available, which in return gives the plant, the healthiest and the most robust growth.
so essentially optimizing it. And like you said, everybody back in the day, 1 pound of light was kind of a standard, and then 2 pounds of light became like the golden standard. And now you're hearing guys 2.5, 3 pounds of light, and even more, with more powerful lights that under canopy. And some of that talking about when you add in, more plants and double stack, what are the signs that the grow probably needs more dehumidification, and how do you kind of recognize that?
So the way that we when we go looking at a new project or an existing, or we're trying to do our calculations, we are calculating everything off of moisture load. So That's the only, if you're able to properly control your moisture with air conditioning systems or HVAC-D or DHVAC, whatever people want to call it, then the cooling portion of it is pretty much going to be solved over and above. So, we have to think of it. You have sensible heat, which is the heat that most people understand,
Right.
and then you have latent heat, and latent is the moisture part of it. I'm trying to make it into a layman's terms, but
Yeah.
you have the thing you feel, and then the moisture. Um, when people look at air conditionings, let's use 5-ton system as an idea. They think, oh, there's 60,000 BTUs in there, right? A portion of that, about 40 or more, is sensible removal. There's a tiny portion of that is actually latent removal. And the latent removal is what we need to focus on. And then if we're only focusing on a 5-ton giving us 15,000 or 20,000 BTU of latent removal, well, then obviously the heat is going to be easily taken care of when we bring that load to perspective. So we're always looking at the moisture side of things. And you don't see many companies doing this, or you don't see many growers implementing this. It's an upfront cost. It costs money. And when people go into these projects, I think I could tell you most always everybody's under budgeted. So when they try to start cutting back things and changing, when we go into projects, and we get owners or operators or builders that really want the project to go very well, and have the best possible equipment, going to be over budgeting the HVAC more than any other component, because it is the lifeline of the project. And for a long
Right.
time, that's kind of been overlooked, in the sense of people just are like, oh, I mean, you drive around LA, oh, you'll see a building and you'll see freaking 125 tons on top of a building. And it's just like, that is there's so many problems with that.
Right.
One thing, it just looks horrible. It's like, yep, there's a big grow.
Right.
Also, the maintenance involved in servicing 120 machines, it's just not the way that it should be done. But for when people came out of the closets and the garages, those were
Right.
trying to build the big facilities, and that's what they knew. So I don't hold them to it, or that's what they.
Right.
There's so much better technology out there, and not even like that it's new technology. There's just proper ways to do this, and that's been overlooked for a long time. When you get involved in the larger projects like we do, the companies that want to do it right, they're expecting way more infrastructure for the HVAC than what the traditional people would expect. Um,
Yeah, that actually leads me to my next question is what is the difference between residential, commercial, and horticultural units, if that is such a thing?
so basically you have residential, okay, which in my opinion should never be used in a grow space. In a controlled environment, agriculture or horticulture environment, it shouldn't be used. Doesn't mean you can't use it in your building for other applications, or you can't use it in your building for other applications. But residential equipment is designed to run periodically throughout a day to keep a home comfortable temperature.
Right.
um, so then you go into a commercial system. So commercial systems are designed for multiple applications, but they're designed to run and be a little more robust. So they're
Mm,
designed to take a little bit more of a beating. Then you go to the next stage, which would be what we would call like precision equipment.
okay.
Precision is designed for a specific purpose, and it's taking into account all of those aspects. So what you would call maybe the horticulture units, um,
Right.
Yeah, that would be considered in the precision world. So precisions have a job or a solution to achieve, and they're built from the ground up to achieve said solution.
Hmm.
Where, if they need to run 24 hours a day, or they need to be able to deal with, cooling under very, very low ambient temperatures, they're all built and designed to do those jobs. Where even commercial isn't directly, that case, and residential
Yeah.
definitely isn't. Um, if you're building anything to produce revenue that is going to pay employees and or be the bread and butter for you or your family, residential should not be used, period.
Right.
um if you got a little grow that's a hobby, or you make a couple bucks from it, maybe go with residential. But if you're relying on it, do not buy residential equipment to use in a cultivation facility.
That's good to know. Yeah, it kind of makes me think about, in my past, I mentioned to you, I come from commercial HVAC too, and not nearly as advanced as what you guys are doing now, but, doing data centers and some of the other projects that, like you said, that might have been, definitely not ambient and comfort cooling like a residential unit. I've definitely seen those different applications, and, it's a good point. And a lot of the things I think that growers may not realize is that air conditioners somewhat can act as a dehumidifier, even though they may not have been designed and should not have been used as that. So a lot of growers have gotten into, separate HVAC unit with a dehumidifier in the room or multiple dehumidifiers. And, the pints per day rating, I don't know if you can touch on that and what growers should be looking at and if they're going to be doing, that type of rating in an HVAC, dehumidification setting, like a full all-in-one, or is it, a standalone? What's your take on that?
Well, let's give a little knowledge on the difference. So you have what's called a decoupled system, which means you have one piece of equipment cooling your space, and you have another piece of equipment dehumidifying your space. So this would be called decoupled systems.
Okay.
Then you have coupled systems, and a coupled system is one piece of equipment that will do both of those tasks.
Hmm.
Cooling or heating your space, and then dehumidifying your space all in one. So for long period of time, even currently today, everyone's buying dehumidifiers, decoupled system. Decoupled
Right.
systems, you have to think this dehumidifier is achieving a task, doing a job, and then it's
Hmm.
producing sensible heat. That sensible heat now has to be controlled by this piece of equipment in order to keep the space cool or temperature controlled. So
Right.
basically, whatever this does, you're having to pay for it to be done again here with this piece of equipment. This puts wear and tear on both of the pieces of equipment. So coupled systems, which would be like any of the products that we manufacture in our DHVAC, systems, we're using one piece of equipment to, at the same time that we're removing latent heat, we're not producing sensible back into the room. We're removing that sensible from the building. So we're able to do things extremely efficiently, which is starting to be more of a standard. I don't remember exactly when it was, but a few years ago, California started pushing, no more HPS lights, right? The light, basically, a light has to meet like it has to be below or above 2 micromole efficiency rating. And so everyone started switching to the LEDs. And obviously, this goes for new builds, not old builds as much.
Yeah.
But they're doing the same thing for HVAC right now. Their municipalities are writing into their, code and standards that decoupled systems are not going to be allowed within,
Hmm.
potentially a year to a few years, because they're just not efficient, and you're using energy to do a job twice when it could all be done once. That was obviously a lot on that part, but pints per day, it's a standard that most people understand. And so even when we're doing all of our load calcs and sharing that with the client, we're going to use the word tonnage, and we're going to use the word pints per day, right? So they understand. Now,
Yeah.
what we're really doing in the back is we're looking at latent BTU, and sensible BTUs, and we're using that to calculate But what we relay back to the client so they understand is pints per day or gallons per day, and tons of HVAC.
And that's helpful because I know a lot of growers do talk in that, sense of, okay, well, what is my goal to remove X amount of pints per day? And then they stack in multiple dehumidifiers, and part of that, you mentioned earlier is the dehumidification is not just the plants, transpiration, it's the irrigation rates. So part of that is, do you take into consideration, the irrigation volume, and does that matter in the sizing and how put together the units for them?
You can look at direct irrigation volume and use that as a metric. We have developed our own metrics, so to say, that we're able to look at plant mass. Sorry, I have to
No,
move.
all good.
We're able to look at plant mass. So what we know is when we go into a project, the first thing we ask for is the amount of watts that are being used in a room. And this isn't because we're just looking at watts and we're going to convert to BTUs, because once again, that doesn't work. But what we do know is that if you have a roughly, 600 to 1,000 watts per 4x4, okay, we can kind of, let's use the word guesstimate or estimate that
Right.
probably have 12 plants underneath it nowadays, 9 to 16, but let's use 12 as a base.
Fair.
Okay. And then off of that 12 plants, most likely nowadays, you're either running a slab with 4x4s on top, which in that situation, we can look at what we know your water volume is projectively going to be. And then the same as if you're using a cocoa 1.5 or a 1 cocoa. Once again, we know you should have anywhere between 12 and 15 gallons of media, right? And so in order to irrigate 12 to 15 gallons of media and achieve a 2.5 to 3.5 pounds out of that said space, our software and our calculations are all stemmed from that. So
Hmm.
we don't need to ask you really your irrigation volume, because if you're doing it right, it's going to be somewhere there. And
Right.
if you're following the traditional program of using rock wool or using cocoa, you're probably going to use those numbers I just told you. So we can stem all of that off of the first question of watts, and then we can get all that data and then come up with the solution. Now, if someone's doing something very different, like using 5-gallon pots or soil, that's a whole nother world. But we don't see much of that anymore, and
Right.
so we don't try to use those numbers that we would need to for that. We're trying to be very standardized in
Right.
whatnot.
Yeah, and you're probably doing a little bit of oversizing as a buffer in that situation.
So it's about redundancy is very key. So let's take a room. If we do all of our calculations and it says that minimal that we need to be able to do what we want to be able to be done in that space is 7 tons. Let's just say, make it a very simple number. So we're gonna put a minimal of 2 units inside of a space at all times.
Okay.
But in a situation like this, we would probably put 2 5-ton systems, right? And
Okay.
so now we're oversizing by 30%. If one unit was to fail, we would still have 5 tons, right? Which is roughly 70% of the initial load. And so
Right.
this would allow a client, these numbers are small, but on a big scale,
Right.
right? This would allow a client to simply push a button and say, hey, dim lights to 65 or 60%, and continue trucking while unit one is being maintenance or repaired or whatever's needed to get it back going.
Makes sense.
So we're always doing things where 70% of the load is always achieved upon system failures. And
That's smart. I think that redundancy does get overlooked. And, one of the questions I did have is, what's the biggest HVAC issue you guys see in grow rooms that causes uneven temperatures and microclimates?
so airflow, so air exchanges in an hour is something that really needs to be thought of. And that is, we are always trying to have 60-ish air exchanges an hour through our equipment. Um, you're never going to get that residential ever. So that's part of, start residential. They're trying to get anywhere between 10 and 20, I think, 10, 15.
Oh yeah, way less. Yeah.
Very, very little air exchanges. So once we can get large volume of air exchange through our system, well, then that's going to help break down the chances of having, hot spots or microclimates and, whatnot. Airflow design is key too. Obviously, you're starting to see a lot of multi-tier stuff.
Right.
Once you get into that, you've really got to think about how that air is moving and where that air is taking on moisture and where it's taking on heat and how to get it kind of back into the loop. Um, we try to design most of our um, systems and equipment where we don't need to use sorry, moving again.
Oh, good.
HAF fans. We try to
Uh,
minimize the use of HAF fans. Now, why? Same thing with ductwork. If we're on a single tier system, 12-foot ceilings, let's say, we can pretty much have no, sheet metal ductwork. We'll use a duct sock, or what we like to use is a poly duct, which is easily
okay.
changeable. It's see-through, it's clear. You can instantly spot there's a problem in that poly duct by just looking up there. Takes about 15 minutes to change 2 or 3 of them in a room when you get good and quick at it. It's very
Yeah.
inexpensive, as little as $1 a foot. Um,
Uh,
and so this will help create the minimalization of the hot spots and the microclimates, while reducing upfront costs because duct work is very expensive, and
yeah.
also while minimalizing a place for pathogens and things to hide. Um, so you get a lot out of that. And then HAF fans, same thing. Like, I don't know, but if you go look in some of these grows that have been around for a while, those fans, when they turn off, they're dirty as
Oh yeah.
people
Yeah.
never turn them off, so they never see how dirty they are.
Yeah. Or they don't clean it. It's a pain in the ass.
it's it's just, it's disgusting. It's another thing that can get nasty, dirty, and create
Yep.
problems. Um, we try to build our equipment for the use that it's being used for, which allows, like, we really try to allow for easy cleaning, where a customer can literally, take a backpack sprayer, put a little solution, so to say, in it, spray the coils down, and
Yeah.
blow them off a little bit and turn the unit back on.
That's
Um,
good. Yeah.
so these are all things that we're trying to bring into our manufacturing process, where the end result is really user friendly. We try to minimalize advanced controls, which is a huge thing that we're seeing more and more. Even yesterday, I had a
Mm.
call with an operator that has a lot of advanced equipment and very specifically built equipment.
Right.
But there is this challenge of what's controlling what. So you might have a Trollmaster, an Agrotech, or a GrowLink, and that's
Right.
tell your AC to do something, but the AC is telling itself to do something else because it has to protect itself. And so
Uh-huh.
we try to minimalize all of that because we're building a piece of equipment that we know 99% of the time is going to be controlled by one of those systems we just discussed, where companies that are big like Aon and AGS and Train, Carrier, those companies, 1% of the time, maybe even less, is their equipment going to be controlled by a system like we just talked about. So it's the complete opposite. So
Mhm.
obviously I don't fault them for that. Their job is they're trying to produce standardized equipment
Mhm.
that works in 99.9% of their applications,
Right.
where we're producing standardized equipment that works in 99.9% of our applications, but that is for the control systems that are in these facilities.
Right. And you touched on this earlier about, the different level sizes. One of the questions is the split systems versus mini splits versus package units. Small, medium, and large canopy facilities all require something different. Can you touch on what maybe is your preference and used for different, applications?
So a mini split is are used even in offices and things. So I wouldn't. They are a residential product in my opinion. Great for common areas, hallways, water rooms, potentially
Yeah.
if it's
Yeah.
small. But once again, if you're trying to make money and pay employees or a family, do not use mini splits. That's just
Yeah.
they're a pain to clean. They have much smaller coil areas, surface area on the coils. Their latent removal is nowhere near what it needs to be. Great for common areas and stuff like that, but when it
Mm.
really gets into the brass tacks, not good. That is all application based, right? So you basically have three types, right? You're gonna have what's a split system would be like a ceiling mounted air handler, let's call it.
Hmm.
Then you have a floor mounted air handler you maybe see in a hallway, right,
Okay.
of facility. And then you would have like a package unit, which would probably sit outside and it would be a coupled product. So air handler and condenser
Mm.
system built into one. So that's really application based. If you are building a facility from the ground up, I would say never use package systems. If you have the ability to build from the ground up and design everything to work right, um,
Hmm.
if you're stuck in an application where you can't put air handlers in your rooms or in your hallways, well, then package is the only option.
Yeah.
But if you're building and designing it, design it so that you can have a air handler in your room or in a hallway or in a above a room in a very easily accessible catwalk system or something like this. That's something that's extremely overlooked. Also, is people don't think about the maintenance of the equipment, right?
Yeah.
So something that you're seeing more, especially in very large facilities, is you're seeing hallway floor standing HVAC air handlers. And this is a great thing because what it allows is it allows easy serviceability. Someone that your maintenance HVAC maintenance guys, they can come in. It's on a ground floor. They can easily walk up to the machine, disassemble it, work on it right there, clean it, do
Mm.
whatever is needed without having to go and crawl into a space or get on a ladder. It's not in the room. So in theory, if you have multiple systems, you can shut down one system, whether it's nighttime, whether your maintenance guy's coming at whatever time of the day, it's not going to
Right.
affect the room. You can turn one machine off, service it, get it back online, turn the next off without that person ever contaminating your space, your grow room. So these are reasons why we think that better application is split, and then obviously putting a unit in a hallway or in a room. There's benefits there.
Yeah, that's smart because I've seen different applications. For example, in LA, a lot of buildings were, retrofitted and they didn't have pads outside or they don't have the roof calculation loads. And there's different variables where splits and or package units sometimes you're forced to go with. But maintenance is always overlooked, especially if you don't come from, an HVAC background. I feel like people that have never, like myself, I had to change filters and I had to do the coil cleaning and duct cleaning. I've had to do that. So I very much understood that challenge. But I feel like a lot of clients don't, and they always want to maximize their cultivation space. And even with the placement, you were talking about airflow earlier, but when the growers are designing the room and doing HVAC install, where should they be placing the supply and the returns in the room?
So there's a lot that goes into that. What we like to have air being returned on one side of the room and then air being dispersed evenly across the room. And
Pass
that
through.
return side, we always want it to be where the door is. Excuse me. Why we like the door to be your return side is so that when a door does open and the air does come into the room, it's being instantly pulled into the stream, being conditioned and returned to the space. This also has to do with, we're putting air purification in all of our systems. So
Mm,
that air is in theory getting zapped before it enters into the world of plants. This reduces, contamination
contamination. Hmm.
like that.
What? What type of treatment do you guys do? Is that UV light or ozone or?
We have a system that we sell. It's just our Triclean Air purifier. It's actually one of the first products we ever made.
Oh
Um,
wow.
and basically, what it is it combines three different air purification methods. So we don't like filters, so like HEPA filters and things like that. Those
Yeah.
are always failing. They get dirty very quickly, and then if you think about it, you're capturing the shit you don't want, and then you're blowing clean air across it. So it doesn't really make sense. So we use what's called bipolar ionization, right?
Hmm.
So what that's going to do is it's going to attach electrons to the air that goes through, and it's going to make them heavy, and they're going to kind of fall out of airflow and stuff. So one thing you notice is that your floors will get really dirty, but it's very easy. You sweep your floor, and then now the dirt's gone. It's not in a
Uh-huh.
filter somewhere, right? The other part that we use a UV style light is inside of the same air purifier. And then we have this plasma based technology that basically is creating what we call on contact ozone. So we're not producing large amounts of ozone and going into your room with it. What we're doing is creating this very small little, almost like a force field of energy. And when particles pass through there, they get zapped with ozone and kind of kills anything. So the
Yeah.
bipolarization does the same thing. So it's kind of zapping it and then making the particles heavy. The UV is zapping them too, and kind of more from a surface standpoint of the particle, where the
Hmm.
other ones are more internally uh, doing it.
Yeah, I appreciate you sharing that because I wasn't as familiar with that process. I've seen a couple different applications, but again, that's something I feel like that's overlooked. And you're right, filters never get changed, whether they're HEPA or just your standard MERV, and it's always something that I feel like is clogging up and creating more problems than benefits. And one of the things looking back at the HVAC systems, I know you do the H or DHVAC one system, as you said, and then there's optional the decoupled, which is AC and dehumidifiers separated. In that situation, is there ever a time that you feel that it's better to go with decoupled versus a coupled system
Oh
and
yeah, of
it's
course.
application sensitive?
Yes, it's all application based. Look, if someone already has a building, and they have air conditioning and they're trying to kind of bulk it up a little bit. There's reasons why dehumidifiers exist, and we obviously produce some, but if there's you have to weigh the options and you have to look at that, right?
Hmm.
Maintaining one piece of equipment is much easier than maintaining two pieces of equipment. Um, and but smaller applications, it's you see I think dehumidifiers are more warranted. Um,
Warranted, yeah, yeah.
yeah, when you get into large application, dehumidifiers shouldn't be in large applications, in my opinion. Then you have which we didn't touch on, but so all of this kind of has been talked about is that we're using what's called a expansion based system, so DX systems, right? So we're using refrigeration gas to create a cooling or a heating effect, and then we're taking the energy out and then basically creating a loop, right? So really the best application or for or the best use of equipment in cultivation would actually be using what's called the hot water chilled water system. So we're going to use water as our energy transfer instead of refrigerant. It doesn't mean there is no refrigeration. It just means the refrigeration is based in a particular unit outside or on in outside, and it's all contained. So you don't have refrigeration lines running everywhere. Water is a way better transfer of heat and energy than refrigerant is in large applications. Once you get water hot or cold, and you keep it going, it's much easier to keep hot or cold. You're not creating an indefinite loop, which that's what a refrigeration cycle is. Once that refrigeration does its loop, it has to be completely redone again, right?
Mm.
And so you're constantly having to input similar amounts of energy for it to keep going. Where hot water and cold water, once we get it to temp, all we're having to do to get it back there is put the amount of energy that's actually needed to create the result we want. So this makes
Mm.
it extremely efficient. Um, that's hydronic systems, and that's what we pushed and try to focus on in the larger applications. And that would be a coupled system where you have one unit or multiple air handlers in a space doing both jobs.
Yeah, I appreciate you sharing this. I feel like that's also something that hasn't really been introduced. As we've talked about in the past, a lot of clients or growers will go to an HVAC company or installer, and the contractors are not as familiar with that as even an option. So they have a tendency to just suggest, 5 to 10 package units, splits, whatever, thinking that that works. And then, yeah, just throw in your dehumidifiers to solve the moisture issue. Talking about optimization and efficiency, the other thing is I feel like a lot of growers don't realize how much money they're wasting in potential electrical loads. And I'm curious, what do you think actually drives the cost of the electrical bill? Is it the lights or the HVAC system?
Whatever you're spending on lights, right? So people always ask this a question I get a lot when new projects. Well, the electrical company's asking me how much power am I going to need, right?
Mhm.
So I always tell people this is the easiest rule of thumb to figure it out. Whatever your lights are, so let's just use watts because that's the base of it. So if you're going to use 100,000 watts in a grow,
Hmm.
you need to have 300,000 watts allocated for said grow total. So it's a 3x multiple. And how we establish that to get there, this is not perfect science,
Right.
but out of hundreds of projects, it fucking works almost every time.
Yeah.
So
Yeah.
you have 100,000 watts going to lighting. You're going to need roughly 1.2 of that to cool it. Because if you just follow the general rule of thumb, 1 watt in, 1 watt out, we need to spend 1 watt of energy to remove it. But really, there's a power factor of about zero point 0.2 or more, depending on the actual efficiency of your equipment. But so that gets us to now you need 220 or you need 120 watts to cool it. So now you're at 220. The other 80,000 watts is just all the other bullshit that's associated with the grow, from cooling common spaces to, this isn't exactly work. This is always overshooting, right?
Mhm.
So then you have really, if you're looking at 300,000 watts, there's a 20% factor on top of that you have to reduce. So really, you're at 240,000 watts. So we're already
Mhm.
almost there with just those two pieces of equipment.
Right.
So yeah, and then as far as energy savings, when you get into this world of large, facilities and you go into like the hydronic stuff, we're able to see up to, $500 or more per ton per year in savings. So,
Mhm.
it becomes a lot of money very quickly that is saved. Obviously,
Yeah.
there's upfront costs. On top of that, there's a lot of rebates that are out there, like the lighting rebates that exist. There rebates exist for efficient HVAC systems. Dehumidifiers they exist for too. HVAC is also able to be rebated, and it could be rebated heavily because we're not talking about small numbers, of upfront costs. We're talking about people investing, hundreds of thousands, if not $1 million or more into HVAC. So these rebates
Right.
are substantial. Um, and the cost that is being, saved over multiple years is substantial. There's even another part that I always like to touch on that most people don't even factor, but people who actually own the buildings, right? So, you've got people who lease and people who actually own. Owners um, get a huge value add when they're using hydronic systems.
Hmm.
Traditional HVAC is basically, even commercial, commercial stuff, is really DX based commercial. Its lifespan is 10 years, right? So if you've got 10-year-old equipment in a building and you own it and that equipment costs $1 million, um, it's not worth the million. It's worth zero today. It's worth zero, literally $0 after 10 years from a resale purpose, or
Right.
from a loan perspective. If someone's trying to get a loan on a building that they're, refi or pull money out, the equipment is zero at 10 years, where hydronics is based anywhere between 30 and 60 years.
Oh,
So
wow.
if you have $1 million worth of hydronic equipment in 10 years, it's only depreciated maybe a third, right? So
Interesting.
so that's a huge thing. And then from a tax, there's aggregated tax savings that can be done. This goes into like the whole world of like real estate and commercial development, but
Right.
when people are investing millions of dollars in these things, especially business building owners, this is where they can save a crap load of money, is by investing it up front into their project and having a better piece of equipment, not just from a growing and cultivation aspect, but from an actual financial model and building savings.
I never even thought about it that way, and you're absolutely right because they can write things off, and it is, like you said, to take a loan against it, or even for future resale value. They don't have to do the improvement or get, negotiated down on that price. And some of the stuff is, we talked about the efficiency, but what are some of your favorite strategies, I guess, with reducing HVAC load or increasing the system's efficiency?
When you get into the hydronic side of thing, it becomes way more efficient because um, you're only really paying for the energy that is actually being used where instead of paying for the machine to run at all times, right?
Hmm.
And then the other part of it is the efficiency comes that when you have a very large facility, everything that's going on in that building is not always the same. And so you can feed that off of the energy from one place and utilize it somewhere else. So it's like a network. So
Mm.
when some rooms are in, need high humidity reduction, but the cooling factor isn't as much, then we can take heat rejection from another area in the building and use that to create that high load of dehumidification in the area. So this is where the
Ah.
efficiencies come, is that it becomes one big ecosystem and you're only going to pay when that energy needs to be dispersed, where multiple little systems, they're always just working and battling. And even on really larger scales where you have, let's say, an industrial building or a commercial building, and it has great sunlight on one side of the building in the morning and then one side of the building in the evening, those rooms on the one side in the morning, they're going to need more cooling, but in the evening they're going to use less cooling, and so the other side of the building can kind of utilize that energy. So these are things that people don't think of.
Right.
These things, we didn't invent this stuff. We're applying real world applications and things that are used in very large commercial projects. We're
Hmm.
finding ways to apply it and put it into the cultivation, commercial cultivation, so that people can benefit from the technology that does exist out there.
And part of that too, over the years of cultivation in states like California, Colorado, and some of the states that have been operating for 5, 10, 20 years almost, what is the ROI you think for a grower when they're looking at upgrading their environmental equipment? It sounds like if you did pay a little bit more up front, you would probably see some savings on the back end if you made the right decision.
Every application is different. It's hard to say that, but look, if you're in a really good state where you can get a really good rebate, um, and you're in a state where you have high utility cost, right? When I say high utility cost, usually associated with power, right? Not so much gas.
Mhm.
Gas is more standardized, and gas is way more efficient at
Right.
doing certain things, which we use gas in the hydronic systems. So if you're in a place where you have high power cost and you have good rebates and you're putting in a large hydronic system, um, the return on investment is within a year. In my opinion and knowledge of that situation, um, because the rebate's going to save you a bunch of money up
Right.
front. So that's going to reduce, basically pay yourself back. And then the cost savings in 1 year can almost supplement the rest of it. We're talking about equipment, not so much the installation portion of it, right? Um,
Fair. Yeah.
so if you incorporate that, maybe 2 years, um, part of it, you're not going to get a rebate on the install. You're going to get a rebate on the equipment. Uh,
Yeah.
so yeah, if equipment alone, you can, in some places you pay it back in a year,
Pretty
especially in
quick.
the large operations.
Yeah. No, that's really quick. And yeah, you're right. The difference in gas versus electrical, supply is very big deal. And every city, state, county has different rates. And I know that because some cities or counties have a limit on power supply and grow operations can't either get their upgrades or they have to wait forever for a substation or they have to utilize a generator. And with that, environmental control, I kind of want to segue into what we talked a little bit about earlier about contamination, but how does your environmental control, tie into mold and pathogen prevention?
So, yeah, I mean, if you have an environment that is not being able to maintain, the big deal is at night. Everyone knows what happens at night. Oh, well, everything spikes at night. Well, there's so many ways that we can properly control that switch, right? With the proper control systems and proper equipment. We can, as that switch starts to happen, we can start to build up and switch from sensible to latent load and force
Hmm.
the latent, removal as that time is getting down. So almost bringing the humidity down almost below the threshold, but only
Okay.
for a short period of time before the switch happens. And so then when the switch happens, we're already below and we're able to maintain much better as the temperature drops. Uh,
Gotcha.
and a lot of that has to do with the control systems that exist out there. And someone being able to properly set up the controls and implement the controls. So one thing that we do, is once we're involved in a project, we're involved as much as you want us to. And most of the time, that's in every aspect that we possibly can. We're not just going to sell you some equipment and say, hey, have fun with it, right?
Right.
We'll walk through the control aspects of it with you. We don't sell the control systems, but we walk through it all with you. There's lots of little tips and tricks that you can do. um, Controls that you can, how you can stage the cooling and how you can stage the temper.
Right.
Most people, I guarantee you go into 20 grows, 8 p.m. the lights go off, 8 p.m. the change in all their environments happen. That's not the way it should be. There should be a taper down, starting at say 7, and then there should be down to 8, and then from 8 to 9. So there should be a 2-hour taper that goes on. And this is setting multiple set points. Now, with just standard, Trollmaster system or something like that, you might not be able to do that. Or a standard, wall mount thermostat, you're not going to do that.
Right.
But with advanced systems, you can build all that taper in, and these are things that make a huge difference within a facility. Um,
Right.
and most of that is user based. The users don't know how to do that, or they don't know it exists. And
Yeah.
so we try to educate people on that and make sure that they're picking the right systems and that they're going to set the right parameters, where they get the most out of what they're investing in.
That's another good point. And another thing is, growers, historically have tracked some of their environmentals or, whatnot, but what data should the growers be tracking daily, to stay ahead of the problems and monitor?
Proper alerts set, right? Shifts and switch, where stuff starts drifting or moving, you start to notice it. That's one aspect of it. Other is, I will send you a picture and you can put it up on the screen here.
Yeah, yeah, sure.
But whenever anyone buys HVAC, products from us, a package style project, we supply them with what we call it's a handy case full of tools, and inside of that case we have a laser thermometer, we have a wet bulb, dry bulb, digital thermometer system. It's a little
Hmm.
device. Um, we have a voltmeter, multimeter tool. Um, and we have a manometer, which is like an airflow meter. So it's,
Okay. With a little fan. Yeah.
and realistically, obviously, we give this to everyone. It's in a nice kit in a case and whatever, but you can buy most all this stuff on Amazon for $200, maybe, right? For
Mhm.
entry level product, it's $200.
Right.
Every grow should have this. This is the key to being able to monitor your environment and make sure, because those sensors are not always perfect, and you should at least once a week or once a month run in there with this little bag of goodies and see where you're at, and make sure that they do correspond properly to what you're getting on your computer screen. um,
Right.
the laser thermometer is great because you can shoot it up and see the air coming out and the air going in, so you can get your
Hmm.
supply and your return and make sure the differentials are where they're supposed to be. The wet bulb, dry bulb, this is going to show you humidity and show you where the evaporation is happening. These are little tools that someone can spend a little bit of time and a little Google effort, and and
Right.
learn how to use them properly and get a lot of data out of it. Nowadays you see all these people with, doing their runoff and doing all those things, which is it's great applications for that and reasons you do that, but no one's doing these other things for the air. They should be.
Yeah.
So we're trying to educate people on that, giving them the tools so that they can, service their equipment and see where you're starting to have shortcomings.
Very great point. Yeah, everybody's keen on doing runoff, or they have probes to collect the runoff, and then they're monitoring that, for their irrigation, but they're not looking at the environmentals, which is another macro input that affects it. And you touched on like some of the controllers, whether it be Trollmaster, BackNet, I know is popular in HVAC. But what are some of the industry softwares that you see that are compatible that you like to maybe suggest or see integrated to help control the units?
So we're old school and we like to keep stuff rudimental once again. BackNet is great, Modbus, great. They have purposes, but they can do a lot of things in one cord, which is great. The problem is when there starts to be problems, the general user won't be able to diagnose those problems nearly as easy unless they have specific equipment. Where
Hmm.
we like to use, dry contacts. We like to
Okay.
have dry contacts that do X, Y, and Z, and then maybe modulating voltage, which these
Okay.
things, a voltmeter and me on the phone, or someone on the phone can walk you through at least figuring out, is this the problem or is there something else? Where Modbus, it's not as easy, right?
Yeah.
It's going to be a lot more. So we try to keep the controls as rudimental as possible, reducing upfront costs, reducing maintenance labor, reducing the need to have an expert on site at all times when it's just one little thing that's causing the problem, and we can look at this. Oh, no, it just, look, that wire's loose, or that saves a $250 call, right? um
Yeah.
these are all the things we look at when we're building stuff and designing it for people, is how to make their life easier, because that's what it is. It's a solution to make the plants happy, and make the operator's life more streamlined and efficient, not just efficient in the aspect of using energy, but the efficient in the aspect of maintenance in operation.
Yeah, that's another thing again with the contractors in general, I don't think is looked at. And you guys, you and I talk to your customer service very heavy in terms of being available for your clients. And that's smart being proactive because you're giving them the tools to help you and them diagnose and troubleshoot in the future. Because nothing ever runs 100% perfect. It's inevitable you're going to run into some sort of headache. Um,
Everything breaks. No one, anyone who tells you, "Oh, nothing's ever broke," someone's lying.
yeah, you
Uh,
haven't been running long enough.
yeah. So, our customer service, we believe, is, bar none. When you call, someone picks up, live person picks up. If someone doesn't pick up, I mean, any time of the day, 24/7, they're going to be calling you back relatively quick, within an hour or so, in almost
Yeah.
all applications. Literally did a podcast maybe, I don't know, a couple months or a year ago or something, where I said, look, you can call us at 2, 3 in the morning. Someone's going to pick up. A guy called at 3 a.m. in the morning, and I picked up the phone actually. And the dude lost his mind. He was like, "You fucking with me?" He's like, I heard you. This is the same voice. You really picked up." And I was like, "Yeah, we pick up. And how can I help you?" He's like, "I'm going to tell you straight up, I don't have any equipment. I don't need any help, but I really just wanted to see if this shit was." I was like, "That's really
Wow.
cool." I talked to the guy for 30 minutes.
That's pretty cool.
He was a
Yeah.
small garage grower. He wasn't in the position to buy any equipment, but he was like, "Wow." He's like, "I wanted to see if what you were saying was real." And
Yeah. That's
that
dope.
um
Yeah, nowadays it takes a while to get a hold of anybody, and that's the issue. Is usually you got to call your contractor HVAC guy, and then they got to call, whether it's Train or whatever units that they're using, and they're trying to troubleshoot, and it's usually during a Monday through Friday, and they're upcharging you, especially if it's outside hours. And part of this too, you guys being, precision environmental controls, how important is that in high-end cultivation? Because you talked about precision, HVAC, and it seems like that's a very, important component for these growers that are really multi-state operators or larger entities.
when you're investing in a project of scale, or trying to scale said project where you can build multiple of them, you need to make sure you're in line really well with the manufacturers, or the the people who are selling you the products, because that's going to be the relationship that determines whether or not you're able to scale and whether or not you're successful.
Right.
So no matter what company you're going with, make sure that they have the understanding of what you're asking in depthly, and that
Hmm.
they have the capability to perform and keep the performance going. Where I see so many times that just falls short, whether it's a lighting company or you know a control company or whatnot. The ones that have the service and can back the calls, they're the ones that become successful, because that's what people want.
Right.
You're not just buying a $5,000 this or $5,000 that. Part of that cost that people don't realize, like it's the infrastructure that we as a company have to be able to provide, and we have to be able to give back and be able to make all of these things happen, so that the service is there and the support's there. We don't have any kind of subscription model. So when we sell you a piece of equipment, we hope that equipment lasts for a long time, but the longer it lasts, the more service and energy we have to put into it. So that's where that cost is. And a lot of
Right.
people don't think of that, and,
It's
and it,
very true.
we are very competitively priced, if not the best price in this type of equipment, because there's no one between us and the end user. We don't use any third party really to sell our equipment. We have a couple of companies that kind of put us into projects, but the price that you get through them is the same price you would get through us.
Mm.
So there's no middleman that's kind of overcharging you.
That's good. Yeah, going direct to the growers is definitely important, especially from the service and price aspect. And one last question before we depart on this, but what would be your one piece of advice for new growers for them to consider with all the things that we just discussed?
If you're going into a project, and someone says, oh, you have X amount of dollars, and you go in immediately in your head, you're going to be like, oh, how big can I make it? Right.
Right.
I can do 100 lights for that money. Do 75 and give yourself a big buffer and do it right. Invest the money on lighting, HVAC, control. Try to figure out how you can do a lot of the work yourself and save that money so you can use it on the other things. And if you can't, then just make sure you budget properly. Whether that's a small scale or a large scale, that applies to it all. Invest in those things. Lighting has always been the thing that people kind of put the most effort into. At the end of the day, most of the time in large operations and successful operations that I've seen, HVAC is way more costful, costs way more
Right.
than the lighting. So make sure you budget properly, design everything, turn everything on and run it for periods of time, and make sure everything's going to do what you want and that it's working and you understand everything. Be very versed on your equipment and your controls, and this will in the long term save you a lot of money and give you better results.
That's good. Well, I really appreciate your time, Cutro, and I look forward to sharing this with everybody. And thank you, man. I hope you have a great day.
Thank you. You have a great day.
All right, guys.
All
Take care.
right.
Thanks for watching, guys.
Yeah, Triclean Air in the building. Boone's Palms, keep it real, no chillin'. Genetics on lock. Climate on point. Let's go. Yeah. Bones Farms, that's the plug. Clean cuts like a scalpel. Tissue culture magic, every strain is a marvel. Pathogen tested from roots to the leaves. Pest-free genetics, no room for grief. Triclean air in the room, airflow straight flawless. Silent dehums, climate calm, no lawless. Foggers in the mist, perfect raw like a kiss. Precision HVAC can't grow like this. Clean jeans, clean air, this can last to wear. Grow room spotless, no mold, no scare. Boone's Palm seated, treat cleanly near feed it. Science in the system, watch greatness breed it. Clean jeans, clean air, no one can compete. From Cali to the globe, we supply that heat. It's the future of the green, engineers so mean. Boone's Farms, X Triclean Air, grower dream team. Boone's bring the pheno structure built in DNA. Triclean Air lock the climate like not today. CO2 balance, humidity low. It's started in motion, watch the champions grow. IPM dialed in, no threats on the rise. Triclean Air purified. dehumidifier, keep the pests outside. Boone's Farms genetics, Triclean Air conditions. Two worlds collide, call it cultivation precision. From the lab to the bloom room, we make moves. Precision cultivation, we don't lose. Genetics X climate, perfect correction. This is what happens when you reprofect clean genes, clean air. This collab too rare. Grow room spotless, no mold, no scare. Boone's Farm seeded, tree clean air feed it. Science in the system, watch greatness breed it. Clean genes, clean air, no one can compete. From Cali to the globe, we supply that heat. It's the future of the green, engineers so mean. Boone's Farms X, Triclean Air, grow a dream team. It's more than tech, it's culture we build. From cone to canopy, every room spill. Boone's Farms and Triclean Air, crafting the perfect air for the world's best gear.